This will be the third and final problem that I give you regarding integration. For this specific example, I'd like you to use your textbook, page 239, section 5.1. It's problem number 11. Now, please go ahead, if you have your textbook with you, get it and open to this page. But just in case, I'll go ahead and read the problem to you. I am going to make a slight correction. I am going to change cubic meters in the problem to gallons, for no other reason than, to me, it just makes it more easily understandable. A village wishes to measure the quantity of water that is piped to a factory during a typical morning. A gauge on the water gives the flow rate in gallons per hour at any instant. Now there's a couple key points I'd like to make here. First of all, did you hear that the function was going to be a flow rate? No matter what, on every problem at least you'll have, and almost always in the real world, when you're integrating, you're taking the integral of some sort of a rate, which means it has two units, something per something, like miles per hour, feet per second, dollars per year. In this case, it would be gallons per hour. The flow rate is about 100 gallons per hour at 6 a.m. and increases steadily to about 280 gallons per hour at 9 a.m. Now basically, that's telling us it's a straight line because the increase, or the slope, is steady. Now, truth be told, the book asks you to find an approximation of how many total gallons will be used. Since we know integration, of course, we can find the exact number of gallons that were used in that 3-hour period. Let's go ahead and take a look at this problem using calculus. Okay, I've put the information from our problem in chart form. For the independent variable, I'm using time. I'm going to start with time of 0 at 6 a.m. as our initial time. 3 hours later would be 9 a.m. Our initial rate was 100 gallons per hour, and it increased steadily to 280 gallons by 9 a.m. Now, since the increase is steady, that tells us that this is a linear function, so I should be able to determine our slope and derive the equation. My slope would be the difference of y's over the difference of x's. So that would be my 280 gallons per hour minus 100 divided by my difference of x's, which would be 3 minus 0, or 3. So the slope would be 60. Therefore, my equation would be 60 times the number of hours since my initial time at 6 a.m. plus 100. Which was, as you'll recall, essentially the y-intercept, since 100 was the initial rate, flow rate, coming into that factory at 6 a.m. when x equaled 0. Now, since I want the total from 0 to 3 hours, I will simply integrate that function from 0 to 3. Now remember, we can always determine what units the integral will give us by multiplying the units of our function f of x times our x, or our dependent variable times our independent variable. Remember, the f of x will always be a rate, for you folks anyway, and our rate was gallons per hour, times x, which was the number of hours. Therefore, the hours cancel, and when we take the integration, we'll get gallons. Now let's actually do the integration and the calculation. When we take the integral of 60x plus 100, we get 30x squared plus 100x, which we will evaluate from 0 to 3. This means I'll first plug in the 3, which gives me 30 times 3 squared plus 100 times 3. When you do the calculation, that results in 570 gallons, minus 30 times 0 squared plus 100 times 0, which is 0 gallons. Now, what we've said is that this was the total number of gallons that had flowed into the factory at time 0. And of course, at time 0, 0 gallons had flowed into the factory. By the end of the 3 hours, 570 gallons had flowed into the factory. Taking the difference and doing the subtraction tells us that a total of 570 gallons flowed into the factory. Now, if you'll recall, when you did this problem initially, back in chapter 5.1, before you knew how to do integration, you came up with this answer. The reason you came up with an exact answer is because the function was linear, and doing either the left and right Riemann sums and taking the average, or by doing a simple geometric calculation, you were able to arrive at the exact area under the curve, or in other words, the exact answer to this question.